Today I'm going to show you how to find and fix slow database queries in Django with the Django Debug Toolbar. So let's get started. The first thing you need to do is install the Django Debug Toolbar. So I don't think I can do any better than the official documentation. If you go to Django Debug Toolbar, their website, and just look at the installation page, follow the steps and get that done. Yeah, I don't think I can explain it any better than this. So that's how you do that, and I'm going to move on to an example that I've got. So this is a website that I've set up where there's a bunch of slow database queries that we're going to optimize using the Django Debug Toolbar. So I'll just take you for a quick tour around this website. It's like a forum. There are a bunch of threads written by users. In each thread there are many comments. All of these comments are made by separate users. Just like Reddit or something. And there's also a set of clubs. Each club has one or more users, and one user can join multiple clubs. So that's our website. Not too much going on, but just enough so that there's some stuff for us to do. And while we're here, let's have a look at this Django Debug Toolbar. So once you've followed the installation instructions, anywhere you go where debug is true on your Django website, which is in development, you'll find this little thing poking around. You can grab onto it, drag it around, but what you really want to do is click on it. And in this there'll be a bunch of panels which tell you very useful things about your application. You can see things like what are your current settings, information about the request, really good stuff for debugging. And what we're interested in today is the SQL section. So this will actually give you a list of all of the database queries that are being run by the Django ORM, or Object Relational Mapper, when rendering this view. So as you can see, there's a lot of database action happening. And we'll get back to this later. But that's just a general overview of the debug toolbar and the SQL section. Cool. So I guess in order for us to really understand what these queries are doing, we need to know what models are making up this Django app, and so that's what we're going to go over now. So this application has 4 models. It has a person, and that's just a user who uses the website, and they have a name. That's cool. So they have a name. It's just a character field, and that's all we need to know about people. So people can create threads, and a thread has a title and a creator. And so here we have a foreign key where the thread refers to a specific person. So there's now a link between our thread model and our person model, and we'll go over this in more detail later. We then have a comment model. So a comment is just like one of these. So on the thread, a person can create a comment, and a comment needs to know what thread it's for, it needs to know what person made the comment, and it needs to have some text which actually makes up the comment. And you can see here that we've got some text on our comment. There's a reference to a person, which I've sort of named user, which is actually like a bad idea, but this is just a foreign key to the person model here, and a thread, which is a foreign key to the thread model. So comment sort of needs to know what user it's for, or person, and what thread it is for. And finally, we have this club model, which is for the clubs page, where a club has a name, which I just called text, and also a club may have many users. Now this needs to be a many-to-many field because one person may join many clubs, and one club may have many people associated with it. So those are our 4 models. Now we're about to do some sort of query optimization in Django, and I think it's good to have a mental model of how these models are actually laid out in the database before we get started. So this is just a kind of demo Django app, and the database is just an SQLite database. And we're going to give it a look by using this DB browser for SQLite app. I think you can get it on Windows, Linux. It's pretty ubiquitous, so you can just find this and download it if you want to give it a try. And yeah, it's got all the database tables in here. So these are a bunch of database tables that Django has put in there. Django migrations, sessions, all the auth stuff. And this is what we're interested in here. Our app is called Forum. And so let's start off with person. So I've made a whole bunch of people in my database, and they all have names, they all have primary key IDs. Nothing too exciting there. If we look at Forum Club, there's surprisingly little data. We just have the ID of the club and the text of the club. For the thread, surprisingly little data as well. There's just the ID of the thread and the title of each thread. So where it gets interesting is when we look at the comment. So if we look back here, you'll note that the comment knows about, it has some text, and it also knows about the user and the thread, and these are foreign keys. And these foreign keys are present in the database here as thread ID and user ID. So on disk, each row, each comment has the text and then the ID of the thread that it belongs to and the user who made the comment. Finally, we've got this many-to-many relation in club, and there's this many-to-many field relating clubs to users. And this is kind of weird. You might have noticed this, that the club doesn't have a user ID associated with it, and the person/user field doesn't have any club information associated with it. So you might be wondering, like, well, where the fuck does this information go? And the answer is that when you create a many-to-many field, Django actually goes and creates a whole new table that maps clubs to users in this case. So every row is just a relation between a club and a person. So this is all for club 17 and all the IDs of the people who are a part of club 17. And then the same for club 18, and these are all the people who are part of club 18. And this is how a many-to-many relationship is represented. Cool. So that's that. That's how everything's laid out in the database, and hopefully this gives you some sort of mental model that we can use later. And finally, before we get started with the actual debugging, it's just good to go over how these views are working. So I've made 3 views: a home view, a thread view, and a clubs view. In the home view, it's just this one here. It just shows us a list of threads. The thread view is for a specific thread and shows you all the comments written by the users. And the clubs view is a list of all of the clubs and all of the users that belong to those clubs. So that's what we'll be looking at today, and that's what we'll be optimizing. Looking at the home view, for all of these I've written sort of a slow version of the query and then faster versions. But basically what we're doing is in this section we're pulling the threads out of the database that we want to show for our forum, and then we're rendering them to a template. And so for the home view, we're just looping over all of the threads in the templating engine and then rendering the thread title and the name of the thread's creator. In the thread view, we're getting a single thread given a certain primary key. So we're just pulling one thread out of the database and then rendering that using the templating engine. And in the thread view, we're going through all of the comments that are related to that thread, looping over those. And for each comment, we're getting the name of the user who made that comment and the text of that comment. And finally, for the clubs, and we'll come back to all of this in a second, we're just pulling all of the clubs out of the database and then rendering those here. And so we're looping over all the clubs, and then we're looping over all the people in the clubs, and for each person we're printing their name. And that's it, that's the whole app. Cool. So let's get started with the home view. So, like a use case or a sort of typical case where something like this would happen, where you're inspecting the queries for a view, is when you load a website in production or in a testing server and it seems kind of slow. And maybe your users are complaining or your staff are complaining, like, this website's too slow, you need to make it faster. Or your boss is telling you that it's too slow. And it can sometimes be hard to, ahead of time, know why it's so slow. And this is why this SQL Debug Toolbar panel is so useful. So if we load the page, and we have a look in here, we can see what queries we're making. And I think the first thing you should notice is that it's a shit ton. It's 27 queries. Now, I just want to point out that these queries are running very fast, 4.84 milliseconds. That is an amount of time that anyone is happy with. That's blazing fast. And so the first thing I want to note is that when you're debugging Django queries locally, these database queries are going to run pretty fast. It's just reading and writing to a file that's on your computer, so the time isn't really a good representation of how fast this is running, really. And another thing you'll notice, I'll see if I can replicate it here. This is saying 27 queries in 4.36 milliseconds. If I run this a couple of times, it's going to jump all over the place. It's 5.7 milliseconds, 4.10 milliseconds. It might be sometimes 1 millisecond. And it also depends on the type of database you're using. And that could be due to caching or whatever. It's very variable, I've found. And to actually get an accurate, like reproducible number locally when running these queries isn't very easy, and what you should really do is focus on the number of queries. And there's another reason the number of queries is important, and that's that typically when you're looking at performance, when you're getting the same amount of data, the one thing that you can fine-tune, and the easiest thing to fine-tune, is the number of queries. So think about it this way. Every single time a query is run, Django has to send a request to the database server, and that might be reading the SQLite file, or it might be sending a request over a network to another machine. And every time there's some latency involved. And so if you're making 27 queries, there is a latency overhead every time. And so you're paying that price every single query, even if each individual query is quite fast. And you can see here, they're all kind of fast. This one's slow, but a lot of these are teeny tiny, what is that? 0.8 of a millisecond. It's blazing fast, but there are so many of these that it slows the whole thing down. So what you want to try and do is take all of these little queries and bundle them up into one big query. So in general, in this guide, we're going to be optimizing the number of queries rather than just looking at the wall clock time, even though the thing ultimately that we want to make smaller is the amount of time that it takes. And another thing as well is the number of queries gives us a good indication of how much our performance will slow down as the number of objects in the database increases. So what I'm trying to say is, like, here we're showing, 10, 12 threads. But if we're showing 20 threads or 100 threads, how is the number of queries going to grow? And that's another thing we'll be looking at. All right, so this seems like a lot of queries. Let's get stuck into it and try and reduce the number. So the first thing that I think you should do when using Django Debug Toolbar is to just look at what the database is doing. So you can see here, if you open this up, that we're selecting forumthread.id from forumthread. And if that doesn't mean anything to you, you can just go and run this in our SQL thing. And we just run that, see what it does. So it's going and grabbing all of the IDs, which is cool. A little bit weird, but cool. And then it's selecting a thread. So it's from the thread table where an ID is 30, 25, etc. So it's going and selecting every single thread. And then for each thread, if you read through this, it's selecting every single person, one at a time. So it's literally walking through a loop and selecting this thread and then selecting this person and then selecting this thread and selecting this person. And this is like the worst possible way to do it. And importantly, as the number of threads grows, the number of queries will grow proportionally. So we have a look at the code, we can see why this stupid thing is happening. And it's because I wrote the stupidest possible code to do this. It's kind of convoluted, you have to go out of your way to write this, but you can see here that I'm getting all the thread primary keys using values list, and then looping over them and using get. And that's why we're having 27 queries. And so the fix to this is to just not do this dumb thing and to use just the Django ORM as it should be used and just use the thread.objects.all. So this was just an example of kind of the worst case, but this actually isn't as fast as it could be still. So let's give this a try, this sort of simple version where you're just getting all the threads and then rendering them. So we had 27 queries before. Let's give this another go. And you can see now we have 15. Now the time did go down, but we're not focusing on that, we're focusing on the number of queries. So that's good, 15 queries. Let's see what happened. So it just kind of looks faster as well. There's less stuff on the page happening. So you can see it is selecting all the threads, and you'll note it's not just selecting the ID now, it's selecting everything in one go. And you can confirm that just by running this, if you're interested. You don't have to do this last part, but you can see it's grabbing all the threads in the title. So this is the data we need. After it's doing that, it's still going and selecting all of the people, one at a time, which is kind of shitty. I mean, it still means that for every thread that you add to this page, a new person will be selected. So the number of queries grows proportionally to the number of items on the page, which isn't what you want. Which might lead you to ask, well, why is this happening? And it's because of the structure of the database. If we go back and look here, if you look at forum thread, there isn't the username in this table. And so when Django goes to look for a thread user's name, it has to get the thread, pull that out of the database, which is what it did here. It got the thread title and the creator ID, which is the person's ID. Then with this creator ID, it went and did a lookup in the person table to get their name. So this means that for every username it wants to render, it goes and does another query for this. And that's because the Django ORM, although it's pretty good, isn't hyper intelligent. It's not going to try and figure this out for you. It's up to you to tell it what to do. So this happens anytime you have a like a foreign key, which I'm going to call like a one-to-one foreign key, which is to say for every thread there will be one creator. Right? So this is a direct foreign key lookup where we're going from the thread to its foreign key relation. And when you have that, that's when you use select related. So I'm going to link the GitHub of this, and you can look at these docs later if you want. But basically select related is for when you want to tell Django to go and get something that's a foreign key. So let's give that a go. So you'll note this is just thread.objects.all. But before we put in the all query, we're telling it to select related. So let's give that a go. Okay, so now we're doing 3 queries in less than 1 millisecond. And once again, I wouldn't fixate too much on this time. It's probably going to be more variable than ever. It's jumping all over the place. So don't worry too much about it, but 3 queries is a lot less than 27 queries. So what we can see here is that there's basically one query that we don't care about. It's like some Django auth thing, another thing we don't care about, another Django auth thing. And then there's one query that's doing everything at once. And so this is select related at work. If you're familiar with SQL, this is equivalent to an inner join on the person table. And so once again, if you're interested, you can copy this in, run it, and you can see now it's selecting both the title and the name in one query, and that's what we want. So when you can, use select related, because it allows you to do everything in one query. And you can use select related when there's a foreign key from the model that you're querying to another model. Cool, so this is as good as it gets, I think. This is, I think, as fast as you can get this home view, and we've done a good job here. And so just to recap, we've gone from 27 queries to 3 queries, which is pretty good. All right, so we've optimized this page. We've gone from 27 to 3 queries on the threads page. Now let's take a look at the clubs page. So we have many clubs, and one user can also be a member of many clubs. A club may have many users, hence the many to many field. And this is 13 queries, which, given the amount of data we're displaying, is like surprisingly little, but we can still do better than this. If we have a look at our 13 queries, we can see it's 1 for each person. So we must be rendering 13 people on this page, and each person needs their own query. We're only selecting, no, so we're getting all of the clubs, and so that's done in one query, and you can check that out if you want. So this is all the clubs we can do. But then for each, what's this one? then it's going and getting so it's going and getting, for each club, it's going and getting all the people who belong to that club, which is interesting. I didn't know it would do that. So the ORM, it's not like super smart, but it's not super stupid either. And so we can see this here where we're iterating over the clubs in the template, and then for each club we're iterating over all of the people and then rendering their name. So just to go over the model again, one club has a many-to-many relation with users. I don't think it really matters which model has this relation, because if you remember in the database, we end up with a structure like this, where we have the club just has its ID and text, the user or the person just has their ID and name, and then there's a separate table that relates each club to the user, which allows a many-to-many relation. So we've already looked at using select related for cases where there's a foreign key. When you have a many-to-many key, you need to use prefetch related. So prefetch related is sort of the second thing you should reach for when trying to optimize Django queries, and it's good for these many-to-many relations. So what we're saying here is Django, when you go and get all of the clubs, could you please also go and get all of the users associated with the clubs that you grab? And so Django won't be able to do this in one query, but it will be able to do it in two, and we'll see how that works. So that's our change. We're just going to use prefetch related because of the many-to-many field. We give this a try now. Instead of 13 queries, we should see like 4 or something. So there you go. We've cut down from 13 to 4 queries. And that was one query for each club, it seems. So as you add another club, before we would get another query. And now, if we have a look, you can see that we have one query to get all of the clubs, which we'll try it here. And I think we've already run this, but just for shits and gigs. You can see it's grabbing all of the clubs and their IDs. And then, where are we at? It's doing a second query to grab all of the club users. And so Django's actually done this query, gotten all the club IDs, and then put them here. And then run another query that selects all of the users that match those club IDs. So it's only going and getting what it needs. It's not dragging up the whole database table. Ooh, syntax error. And you can see here it's getting all the usernames that we want. And you might note it's actually probably getting the same username twice. I think I saw Debbie in there like 100 times. So, yeah, Debbie. So that's interesting. I didn't know it would do that. It's not hyper efficient, but it's certainly better than, what was it? However many queries it was before. And once again, this is fetching redundant data, but it's probably better because it's fewer queries, and fewer queries means less latency. And most of the time, it's latency that's the killer, not the amount of data you're dragging up. So there you go. We've used prefetch related on a many-to-many field to cut down from 13 queries to 4 queries. And I'm also confident that if you add another club, the number of queries won't grow, which is good. It's a good thing, especially when you expect there to be more data in the future. Cool. So we've done the threads page. We've done the club page. Let's finish off with the individual thread page. So this is a single thread. I think I've gone and messed around with this already. Yeah, I'll just change this back to how it was. Show you what it should look like. Right, so we have a thread. It's a single thread identified by this sort of thing in the URL, this PK in the URL. And this thread has many comments. Each comment has some text and has a user who has a name. So if we have a look at that in the database, you'll see that we've got one thread and we have comments that know about what thread they belong to, and the comment also knows what users belong to that comment, and then the user has a name. So there's actually 3 models here. And the relation goes that the thread is going to ask for all the comments that belong to it, and then each comment is going to ask for the user that belongs to it. So there's sort of a double hop here. If we look at how this is queried, you'll see we're taking the primary key that comes in through the URL, we're grabbing one thread using get, and then using render to sort of use that thread to render the page. If we have a look at the HTML, you can see that we're rendering the thread title, which is probably free, and then looping over all of the comments in the thread, and for each comment we're going to render the comment text and the comment user's name. So here we'll actually be making a new query here every time because we're asking for the comment user. So let's have a look here at the SQL pane to see what's going on. So you can see we are selecting all of the forum threads, and if you don't believe me, I will execute that in SQL. No, sorry, no, I was wrong. It's selecting one forum thread, so it's using where ID equals 19 to just get the title and the ID of the creator, which we don't care about in this case. And then it's actually being relatively smart. It's going and actually getting all of the comments in one go. So if we have a look at that, it's going to the comment table and it's getting all the comments at once. So it's actually not that bad. And this is because we used commentset.all. This is a reverse foreign key lookup to look at all the comments that are pointing at this one thread, and we've just asked for all of them, and Django, being not that dumb, has gone and done this in one query to fetch all of the comments. And so you would think like, well, what else is there to do? Problem is, for each comment then, we're asking for a user, and the user is in a different table. So if we have a look at that, if we go to the comment, you'll see it has a user ID, it doesn't have the username. So even though Django's gone and fetched all the comments we need, it hasn't fetched all the usernames we need because they're in this table here. So this results in a new query for every username, which means that for every comment on this thread, there will be one query. And we can see that here, where it's selecting from the person table a bunch of times, and you can see it's selecting just for a particular ID every time. So it's going and doing a query for every person. And this is the sort of thing we want to prevent because it's like sort of pointless, has a lot of latency and overhead, and we want to bundle all of those up into one query. So just as an experiment, let's get rid of all these references to users and see what happens. If we just get rid of this reference to a user ID, and instead of having a username, we just call all our users Alice. It's now just Alice's forum. Refresh the page. You can see now this is 4 queries, which is more what we're aiming for. And so this sort of just twiddling proves to us that it's the selecting of the user that's doing the extra overhead. Let's change this back. So this one's a bit more tricky. This is the trickiest query optimization that we'll do. How are we going to get from 29 queries to like 4 or 5? So we've already seen how to use prefetch related for a many-to-many field. This is a little bit different. We're going to do prefetch related to go over, how to put this, this is hard to describe, but we're going to use prefetch related to tell Django to select a over a hop. I'm not sure how to really say it, but basically we want to tell Django when it goes and gets all the comments that it should also go and get all of the users. So it's going from thread to comments to users or person. And so the way we tell it to do that is with prefetch related here. And this is like this sort of zany Django syntax. So you'll note that the thread has a comment set and we want to prefetch that, but that's not enough. We also need to then go tell it to look even further and look at the user relation on the comment set. Now this syntax is like, if you're reading this and saying like, what the fuck is this? That's pretty normal. This is very Django specific syntax that takes a while to get used to. And and I recommend that you have a look at the prefetch related documentation on this. But basically you feed it a string that tells it to look at all the comments and to prefetch those, and then to also prefetch all of the users that are attached to those comments. And this gets so complicated and hard to visualize that it's not always obvious how this will work or whether it will work. And that's why Django Debug Toolbar is so valuable, because you can check very quickly in development, like, did my query work? Did it actually reduce the number of queries? For example, if we were just to do this and maybe didn't think about it too hard, which I did earlier, maybe you think that this would fix the problem and reduce the number of queries. But when you go and try, it's actually done an extra query. So we've made more queries, not less. And that's because we need to tell it to go and get the users as well. So prefetch related gets kind of hairy, especially when you're doing jumps through objects to other objects. And you can do some really crazy shit with this. And I guess I'm just trying to tell you, don't beat yourself up if you struggle with this and need to experiment a lot. And that's what Django Debug Toolbar is really good for, experimenting with this stuff. So now that we've found a query that we think works, let's give it a try. And we do it in 6 queries, which is cool. Let's have a look at what we're doing. So 2 of these queries are to do with authentication, which we don't care about. We are selecting, let's see, the thread. And it's actually going and selecting the thread a second time. It's actually doing the same query twice, which I don't know why it's doing that. It's actually doing that in the prefetch related and the get, which is interesting, but whatever. So it's doing some weird duplication. It's then going and getting all of the comments here, and then it's doing this prefetch sort of query where it's getting all of the people with IDs that match these IDs. And these would be the IDs of the comments that we just wrapped here. So that's how that works. If this doesn't make sense to you, fair enough, it's a little bit crazy. I recommend you download this Git repo, boot it up, and give it a go. And just sort of experiment around with this and have a look at what queries it's making, have a look at the database structure, read the Django docs, and hopefully you'll get there at some point. Cool, so I think maybe that's not perfect, but it's a lot better. And we can also expect that as we add more comments, we won't get more queries. I think the wall clock time is faster, although that's not the most important thing in development. But there you go, that's how you use prefetch related to do, I guess, queries through objects. Okay, hope you've enjoyed the video. Just to recap on what we've learned how to do, we've learned how to use Django Debug Toolbar to see what queries are running in our views. We've learned how to use select related for cases where there's a direct foreign key relation. We've learned how to use prefetch related for cases where there's a many-to-many field. We've also used how to learn prefetch related to do more crazy things, like reach through objects to grab other objects, like in the case of going through a comment to get at its user. So yeah, hope you enjoyed the video. Go out and give it a try on your own code base, install Django Debug Toolbar and see if you can optimize some of the queries that you're running in your views. There's also a GitHub that I'll link in the comments and on the blog post, which you might be interested in poking around the code that I've been looking at today. And also, if you're interested in deploying Django, I've done a video series on that, which takes you step by step through how to deploy Django to a Linux web server, which if you like this, you might like that as well. Thanks, bye.